100 years ago, one visionary set forth upon a scientific journey of the mind so profound that it forever changed the way we live our lives and view the universe. Practicing physics on the sly, and with very little personal interaction with the scientific establishment at the time, this unknown patent clerk in Bern, Switzerland, named Albert Einstein, wrote 5 seminal papers in 1905 that encompassed the whole of the universe, from the workings of the atom and out through space and time. During the course of that 1 year, the brash 26-year-old Einstein helped clinch the then controversial case for the existence of atoms. He proposed that light is made of particles of energy, and he began to turn the tables on Isaac Newton's laws of motion, laws revered for more than 200 years. He said that space and time were relative depending on one's frame of reference. Traveling at light speed, time slows down so that 1 second will linger for an eternity. He also realized that matter and energy are interchangeable. E equals mc squared. Einstein's theories set the stage for the technological revolution that defined the 20th century. Lasers, electronic sensors, nuclear fusion, all point back to one man and one miraculous year.
Einstein had a way of working, but it was really his stubbornness that made him stand out. He didn't take for granted what other people were saying. He realized that gravity was different from all the other forces of nature. General relativity says that gravity is not a force, but it is a feature of space-time.
Einstein's theories on gravity, space, and time led to startling outcomes that in some cases Einstein himself could not believe. The universe is expanding and is not static, as was thought at the time. We now believe this expansion is caused by a big bang. His equations also revealed that regions we now call black holes can cause space to buckle and bring time to a halt. Recent technology has propelled an explosion of new findings, raising new questions that Einstein's theories do not address. What powered the Big Bang? What happens at the edge of a black hole? And what is the mysterious dark energy that is now accelerating the expansion of the universe? We've been at such crossroads before. The scientific revolutions spawned by Isaac Newton and Albert Einstein were a result of the growing inadequacy of established theories of their times.
We're sort of at that stage again, where despite our vastly more sophisticated understanding now than in 1905, we now have results primarily obtained from astrophysical observations, which are simply not accommodated in our theories.
This is where NASA's Beyond Einstein program begins. Scientists have set a course, a well-coordinated mix of facility-class spacecraft, probes, and Pathfinder missions, each with powerful new technology to explore the extremes of nature, the Big Bang, black holes, and dark energy. For it is here that the current theories begin to crack and answers are revealed.
To really understand the laws of nature, we have to go to these extreme environments and study them to give a hint of the true fundamental laws of nature.
People are talking about doing precision cosmology for the first time. Because it used to be cosmology, well, we have a rough idea how big the universe is, maybe to a factor of 2 or 3. But now with these new measurements, we're really getting a handle on the overall density and structure of the universe. And what they're telling us is not what we expected to hear.
Well, the biggest mystery today in all of science is dark energy. Why is the universe speeding up? It's a fantastic puzzle, and we're quite confident that when we figure it out, it's going to give us answers about other important puzzles as well.
Since 1998, something totally unexpected happened, which is we discovered that not only our universe is expanding, this expansion is accelerating. This is a classical who ordered that type situation. 70% or so is dark energy in the universe. You know, about 70% of the surface of the Earth is covered with water. Imagine we didn't have a clue what water was. This is the situation we're in.
A mysterious force propelling the universe? Ironically, Einstein proposed such a force to counter the inward pull of gravity and to keep the universe static, which was the belief 100 years ago. He called this the cosmological constant, a vacuum energy of empty space. When Edwin Hubble discovered the expansion of the universe in the 1920s, Einstein called the cosmological constant his greatest mistake. But the mysterious dark energy we see today may well be a manifestation of this cosmological constant. Einstein was perhaps right, after all. Richard Feynman and others, who developed quantum theory, realized that empty space was full of temporary or virtual particles continually forming and destroying themselves. Physicists began to suspect that the vacuum of space ought to have a repulsive form of energy generated from these virtual particles, but they could not predict its magnitude. We still do not know whether the highly accelerated expansion in the early universe called inflation and the current accelerated expansion due to dark energy are related. A space-based mission called the Dark Energy Probe, to be jointly implemented by NASA and the Department of Energy, is being planned to measure the expansion accurately enough to learn whether this energy is a constant property of empty space, as Einstein conjectured, or whether it shows signs of the richer structure that is predicted in modern unification theories. This mission will be a major step in tackling the mystery of dark energy.
For the first time, we actually have an inventory of the universe. But if you look at the accounting, 95% of the stuff is in forms yet to be fully understood. And so we know a lot, but we understand much less.
And among the 5% that scientists call ordinary matter lie yet more mysteries, the most perplexing of which are black holes.